Okay, so now we'll talk about repetition statements, or loops. Loops are code structures that repeat in actions until some kind of ending condition is met. It could be things like accepting user input until the input is valid, for example with a username-password combination. It could be initializing a set of array elements, so you start at the first element, and as long as there are more elements remaining in the array, you keep on going and initialize the next one. And things like data sorting algorithms. Basically, you have a starting point, which is some set of mixed scrambled kind of data, and then at the end, you check to see if it's all been sorted, and when it is, it's done. So, there are three basic approaches to loops. First, in Java, there's a while loop. In a while loop, there's a test condition, and then you repeat the actions as long as that test is true. In a do-while loop, you do the action first, and then you check the test, and then you repeat the actions. There's also a special kind called a for loop, which is just a clearer shorthand for a while loop. So, I'll draw a quick picture of all these. In a while loop, you have some Boolean test. Alright, so that test there will resolve to either true or false. And then here, inside, you have loop statements. So the basic sequence for a while loop is first, do the test. If true, execute loop statements. If false, skip the loop block. Afterward, after all the loop statements are done, retest. And once again, if true, repeat the loop block. If false, then you're done and you skip the loop block. Repeat until test is false. Okay, so that's how a while loop works. A do while loop, you have do, and then again some loop statements. While test. So, first, execute the loop statements. Afterward, test. If true, repeat the loop statements. If false, skip over the loop block. And again, repeat until the test is false. So essentially, the only difference between the do loop and the while loop is this. If I copy this, I put these statements ahead of the while loop, then I'm dealing with the same structure. I'm doing the statements once first, just like in a do while loop. Then I execute, then I check the test. If the test is true, I keep repeating, just like in a do while loop. I check the test, I keep repeating until it's false. So that's the only difference. Okay. So simple introduction there. Now, let's go over the syntax. So, in a while loop, the test condition is checked first. Right? If the condition is false, we skip it, otherwise executes and goes on. So, the test condition can be independent of any code in the block. Could be used different variables, and the loop block code might or might not directly affect the test condition. For example, you can do a very simple test. If you want to make an infinite loop, you can write in something like while true, and that's just the literal Boolean true there. Loop statements. In this case, this is an infinite loop and will not end except by a break statement in the loop, just like we saw with switch statements earlier, or returning from a method. Okay, so you can make a very simple infinite loop that way. Okay, basic syntax of a while loop looks like this. While, and then some Boolean expression in parentheses, then inside squiggly brackets, you have the loop block statements. And those braces may be omitted for single statements. Just like with an if statement, if there's only one statement following the if test, you don't need to put it in braces, but same thing with while loops. Okay, so as an example, suppose you want to ensure valid input. We have this. We create some scanner object called input. We assign an initial value of empty string to a string s, and then initially we assume we don't have a valid input, so we set a boolean to hold the value false. And as long as that boolean is false, so we have while not is valid. So while is valid is false, not is valid is going to be true, thus this test is true, and we're going to repeat the loop. It'll prompt us to enter a name, so enter your name. It'll read the next line of user input through the console, so input remembers our scanner, dot next line reads the whole line of text, and we assign it to s. So if this ends up being a valid input, at the end when we come out, s will hold that input. Then for our validity test, we just say if the length of s is greater than 0, so if there's at least one character the user has entered, then we consider that a valid input, and we'll set is valid to true. So if the user has not entered a valid input, is valid will still be false. We'll go back here, not is valid will be true. But if the user has entered a valid input, then is valid will be true. We'll go back up here, not is valid, not true will be false. And so we'll skip over the loop and we'll say system.out.println, hello, whoever you are. Okay. Now, do while loops, like I said, loop block executes first, and then the test condition is checked. So if the condition is false, the loop block is skipped. Otherwise, it executes as long as the test condition is true. So the difference is, unlike a while loop, a do while loop block must execute at least once. Doesn't necessarily mean it's going to execute one more time than an equivalent while loop. It just means it's always going to execute at least once. Okay, so basic syntax. Do, then squiggly brackets, inside the squiggly brackets, the loop block statements, and then afterwards while and some Boolean expression. And again, the loop braces may be omitted for single statements. So, same problem as before. Suppose we want to ensure valid input. Okay, we can do this. We can say, create a scanner object, create a placeholder string for our user input, and have a Boolean variable false, right? Again, is valid. So here, instead of checking the test first, we just assume, well, I need to get a user input. So I do that. I do enter your name, read the input, and then I do the test here. If the length is at least 1, then I assume it's a valid input, and I set is valid to true. After I've done that, I say I do the test here. And if the test was valid, right, if the input was valid, then is valid will be true, and thus not is valid will be false, and I'll skip on to the print line. Otherwise, if the user entered a 0-length string, like they just hit enter, then s.length will be 0. If you're trying to do this at home, by the way, there should be parentheses there in s.length. Okay. Anyway, so if the user input was false, then I'm going to skip this. Length will be 0, thus is valid will remain false. So when I do the test, not false will be true, and true, so it repeats. Okay, and it'll keep repeating until I enter in a valid input. Now, like I said a moment ago, do while loop and an equivalent while loop might execute the same number of times. Do while loop will always execute at least once, but the equivalent while loop might also execute at least once. So here we have a case here. We have an initial value for x. Inside the loop we're adding 10, and we're keeping on doing that while x is less than 10. So if we start off with x is 5, we have the do, x 5 plus 10 is 15. We do the test while x is less than 10. That's going to be false, so I'm done, and x will be 15. On the other hand, the equivalent while loop here, I set x equal to 5, and I say while x is less than 10, add 10 to it, so 5 plus 10, 15. Is 15 less than 10? No, so I skip over it in the second iteration, and then I'm done, and x is 15. Now, on the other hand, if I started off with the number 15 for x, I said int x equals 15 here. Let's go ahead and we'll make that edit here in the slides. If x is 15, I'm going to do the loop there, and 15 plus 10 is 25. Then the test will be false. 25 is less than 10, and I'm done, and x will be 25 at this point. On the other hand, if I do it in a while loop, if I say initially x is 15, I check is x less than 10? No, it's not. So I skip over, and at the end here, x is 15. So do while loops and while loops, they are different, but sometimes they can take you to the same place. But certainly you have to be careful about it. Okay. Anyway, the equivalence here, This is the same thing I did a few minutes ago. Essentially, a do loop is the same as a while loop with the loop statements in front. All right. If you wanted to make a while loop the equivalent of a do while loop, you would just ensure that in the first pass through the loop, this Boolean is true. And then if that's the case, then your while loop will always execute once as well. Now, choosing between a while and do while loop. In most cases, either kind of loop can be workable, so it's not usually a critical decision. Bigger picture, coding can optimize any of the following things. Memory usage, execution speed, those are performance issues, basically how well your program runs. The other two are human issues, how easy it is to write code, how easy is it to maintain and update and share with other people. So, quite often these days, especially with code that's written in Java, computers these days mostly tend to run well enough. You don't have to be super focused on memory usage or execution speed except for really high-scale systems. On the other hand, you always have to be concerned with the fact that a lot of people in the organization might be looking at your code and need to understand it. So quite often, you would think these first two would be critical. Often not so much. Often it's these two that are a bigger issue. So it's a good practice. If you're writing an application, what you want to do is model the easiest way to think about the program, right? Don't make your other programmers think too hard about this. So a do-while loop is generally appropriate if the loop will definitely need to happen at least once. For example, if you're giving a prompt for a user to enter some input and you definitely want them to enter an input at least once, it makes sense to do a do-while loop. On the other hand, a while loop is suitable if sometimes the loop shouldn't execute at all. For example, you're running a query to a database, the database returns you the set of matching results. A lot of times there will be some results to display, but sometimes there won't be, right? Sometimes you'll enter some query string and it just won't turn up any matches. In that case, a while loop might be more appropriate because you would run the query and say, while results exist, display the results, right? But if there aren't any, then there's nothing to display. Okay. Final words on that is, again, it's usually not a critical decision. You can usually make your program work one way or the other. It's just the other way will usually involve a little bit more contortions than the right way. Okay. Last thing, if I recall correctly, is a for loop. For loop is a simple shorthand of a while loop, and there are three components in a for loop. An initialization, that's some code that gets executed before the test condition gets checked. Of course, the test condition that determines when the loop repeats. And an optional ending statement, which is typically in a for loop an increment of the index counter. But we'll talk about that in a moment. Initialization and ending statements can both contain multiple statements separated by commas. So, simple example of that, right? So imagine if we have some while loop. Starts off with some initial statements, and then we actually have the while loop itself, while test, and then loop statements, and then afterwards, I'll call these the last loop statements. Okay? A for loop basically takes these things and brings them together in a very simple header. So the format for a for loop is for initial statements, test, last loop statements. Okay, and then over here the regular loop statements go inside, so I'm just going to cut and paste those. Okay, and all of these have their exact counterparts in the while loop. The initial statements go here, the last loop statements that didn't work out well. The last loop statements go here, and then the test goes there. So these three things, let's recolor you. It shows where they are, right? The test happens there. The initial statements are the first thing in the for loop. If you have more than one, they get separated by commas. The test statement, all right, the test condition is there in the middle. The last loop statements go at the end. And this, since the first two are optional, this can lead to some weird looking but valid code. For example, you could have something like for, all right, if we do this, int x equals 0, x equals 1. We could do for we could do this. And it looks a little weird to say, oh, here's a semicolon just hanging there out in the middle and not really doing anything. But that's legal. That just means we don't have anything here that would be the initial statements. So we start off with x is 1, and in our loop, as long as x is less than 10, we print out x and increment it. So the last time we'll do this, we print out 9, right? So if x is 9, then it's still valid and we continue. We print out 9, we increment x to 10, x becomes 10, the test condition is true, and we skip out. Okay, so some syntax examples then. Basic one here, suppose we want to initialize two variables, int x equals 0 and int y equals 1. So these are separate statements, again, separated by commas for the initialization. They happen before the test condition ever happens. If this condition is true, x is less than 10, which going into the loop it will be because x is 0, then we execute the loop block. Here we're printing out x and y squared. Then, after these loop statements, we increment both x and y. Again, these are separate statements separated by a comma. So, interesting quirk about Java. We can discuss this during lecture sometime. Any variables declared in the initialization of a loop have their scope limited to the loop block. So this is one of the weird cases where you can actually have double declaration within a method. So I'll do a simple new class here. Pick a project. Call it loop stuff. Okay, now if I want to make a loop here, I'll do this. So first, for int x equals 0, x is less than 10, x plus plus. And then inside the loop, system.out.println x. Okay, now at this point, I couldn't put an initialization of x here. If I did this, again, there's an error here because it says duplicate local variable x. I've already declared x here and exists for the whole scope of the method. But if I do an x inside the for loop, then its scope exists solely within the loop. And if I wanted to, I could do another int x equals 6, for example. And there's no problem because this x only exists in a portion of the method, right? Exists only within this loop. It's a strange quirk of Java. But the idea is, if you have a bunch of loops, you can use the same index label for all of them. If I wanted to, I could just have it be index equals 0 and do it as long as index equals 10, less than 10, and increment it, and then print it. Because often you don't want to have to think about entirely new variable names, right? So if I have a second for loop here, I could do exactly the same thing. I could just cut and paste that. Okay, and there's no problem in this case. All right, and this other quirk here, omitted initialization or ending statements are just left vacant in the for statement. So if I didn't have anything here as an ending statement, I could leave that out. In this case, though, I would have to have something here, index declared here somewhere, because otherwise index doesn't exist. So I could do index index equals 0 here. And then it covers all downstream code there. Okay, a few more things to cover. So, number one, incrementing is very common as a ending statement for a loop, for a for loop, but any other variable change or other statement can be included. For example, in this case, I include a string assignment and then printing out the string. So it doesn't have to be an increment or a decrement. And in this case, the loop statement itself is incrementing x and y. Another one. Commonly, loops are used to initialize arrays. We covered them in the lecture now, but at the time I lectured on loops we hadn't. But you can do other stuff with them. For example, if you want to count the occurrences of certain substrings in a string, have this code. Take a look at it. But basically, text is some giant slug of text that we're reading from a user interface, a GUI graphical user interface. The substring is some user input for the text we're looking for. For example, if you want to find a string of text inside a long article of text, The count is the number of instances, number of matches we find. And basically this for loop here will continue looking through the entire string, and each time it finds a match, it will increment count by 1. All right. So key things to remember for loops. These are some warnings, not so much directly tested, but things to be aware of when you're coding. Number 1, after the loop, any conditional test variable will have the first value where the test is false. So in this loop, if we start off with x is 2, and each time through the loop we double it, so we go 2, 4, 8, 16, 32, 64, 128. We get to 128, the test is still false. When we double it once more, it becomes 256. So at that point, when x is 256, this is false, we go out. We print the loop here, we'll print out the number 256 because that's the first value of x where this test was false. It won't be 128, the last one where it was true. Okay. Number 2, good principle, loops should progress towards completion with each iteration. If you wanted to execute a particular number of times, you should somehow make it get closer to that, typically by incrementing an index counter. So for that, increment and decrement operations are preferred. Inequality tests are often dangerous, especially with floating point numbers. So an example for this, something that goes wrong here, we're multiplying x by 1 instead of adding 1, so each time the loop's never going to end. We start off with 0, but 0 times 1 is still 0. Based on just this loop, all it does is print out x. X is never going to be not less than 10, so it's always just going to be 0. Likewise here, we have our test condition z equals exactly 10.0, but each iteration through loop, we start off with 0, and we add what we think is 1/7, but in fact, due to rounding errors, this isn't exactly 1/7, and z will never exactly hit 10.0. It'll just keep on sailing along. I can lift that little bit of code, and you can see here in Eclipse. So this I'll do, and we'll just run it. We're going to print it out. So boom, before I even know it, we're just off and running. So inequalities, inequality tests, they're very dangerous to do with floating point numbers. Okay. Third one, rather than checking exact numbers, in this case there's a problem with float because you have a limited number of decimal places. So float isn't going to end up exactly where you think it is. So when we start getting into bigger numbers here, that 103, we're only going to have 5 decimal places afterwards, and so this will not be the exact match that we're hoping for. It's generally better if you absolutely must use floating point numbers in your loop, it's better to include a margin of error. So in this case, we're going to repeat the loop as long as x is outside the range of just under 103 and just over 103. If it's a little bit far away from 103, then that's okay. We're going to keep on going. So we have to make sure that this operation, each time we're adding 2/3 to our initial value of 1, eventually we get pretty close to 103, close enough that the loop ends when it's supposed to. Last thing, number 4, beware the overflow. So if you're talking about integer types and you add numbers to it or do some multiplication, the calculation will be performed, but the result gets fitted into the type's bit length. And remember, for all integer types in Java, well, for all signed types anyway, the highest bit is set. If the highest bit is set, the value will be negative. For example, the highest positive value for a byte is 127, which corresponds to, in binary, this, right? So say byte 127 comes out to 0, 1, 1, 1, 1, 1, 1, 1. If I add on 1 to that, okay, so if down here I do something like plus 1, then underneath, all right, the addition is going to resolve to 1, 0, 0, 0, 0, 0, 0. This is, in binary, this is the equivalent if I have 99,909,999. I add 1 to that, it becomes just 10 million. Same kind of thing. So this, though, Java will interpret this value as negative 128 plus 0, which of course equals negative 128. So remember the warning in Java, 127 plus 1 could equal 128. Does equal if the type is byte. Okay, and all the integer types do that same thing. When they reach their highest positive value, if you add 1 to them, it gets bigger. Similarly, if I start off with the value 64 for a byte, we need one more? We need one more. If I multiply this by 2, right, so I'm going to do this. Okay, that net result becomes what? Well, this is 64. This is times 2. Of course, it should equal 128. But in Java, again, because of the byte problem, right, the type problem, I end up with this, because I'm multiplying by 2. Basically, I'm shifting all the bits 1 left. I end up with this, which equals not 128, not 128, but, as you know, negative 128. Okay, so again, in Java, for type byte, 64 times 2 equals negative 128. So this is something you have to be aware of. Basically, the math is going to happen, but if you have an overflow, the number could flip around, become negative, or otherwise some unexpected value. Likewise, I'll mention, if you take this number, negative 128, and you multiply it by 2, you do the same thing where this 1 shifts 1 more column to the left, and it gets replaced by a 0. Well, all these zeros simply evaluate to 0. So again, in Java for type byte, negative 128 times 2 equals 0. If you don't understand overflows, then yeah, these results will be very unexpected. For floating point types, though, it's a little simpler. Any value that exceeds the floating point maximum value, so example, 10 to the 38th for floats and about 10 to the 308th for doubles, it's going to come out as infinity. So here if we have double D is negative 10 to the 308th. If we multiply that by 10, it becomes negative 10 to the 309th, which is outside the allowable values for a double. It just evaluates to negative infinity. And that's actually what you see in Java. Okay, and that's it. Any questions? Come by and ask me during lecture.